Today's lesson is on geometric sequences and series. In a geometric sequence, consecutive terms have a common ratio, and we use the letter R to denote that ratio. To find the common ratio, divide any term by the previous term. So the first thing we want to do is make sure we know how to identify a geometric sequence. We want to make sure there's a common ratio. So what we want to do is take the second term and divide it by the first. So 6 divided by 3 is 2. Now I'm going to go to the next term and divide it by the previous term and see if I get the same thing. 24 divided by 12, that's also 2. So we see we have a common ratio, and this one wasn't very hard to define. We could see that we're multiplying by 2. Now, let's look at this next one. Oh, so it says, is each sequence geometric? So the answer here is yes, and the ratio is 2. It says, if so, what is the common ratio? So let's look at part B. 8 divided by 4 is 2. 12 divided by 8, ooh, that is not 2. So this one, no, this is not geometric. Okay. As a matter of fact, it looks arithmetic. Yeah, this one's arithmetic. We have a common difference. Okay, for C, let's see. -3 divided by 1 is -3. 9 divided by -3 is -3. And -27 divided by the previous term, that's -3. So yes, and the common ratio is -3. So you'll notice sometimes the ratio is positive, sometimes it's negative. And notice how the signs go back and forth here. Let's look at D. 16 divided by 32 reduces to 1/2. 8 divided by 16 also reduces to 1/2. 4 divided by 8 is also 1/2. And 2 divided by 4 is also 1/2. So the ratio is 1/2. And yes, this is geometric. Let's look at the last one for this. 3 divided by 2 is just 3/2. 9/2 divided by 3. Remember, you divide by the previous. So we want to multiply by the reciprocal. What is that? 9/6 reduces to 3/2. So that's 3/2. Let's do this one. 27/4 divided by 9/2, or we could say 27/4 times 2/9. And again, we get 3/2. So that one was a little harder to see, but yes, we have a common ratio, and that ratio is 3/2. You always just divide by the previous term to see if you have a common ratio. Now, A sub n for a geometric sequence is A sub n equals A1 times R to the n minus 1. Make sure you memorize this formula. This is A sub n for a geometric sequence. So now, let's see what we can do here. First of all, we're just multiplying by 2. It's kind of easy to see that ratio, and that is common ratio. So now we want to plug in to this formula right here. Or actually, a sub 6, that is so close. All I need, that's 1, 2, 3, 4, 5, 6. So the answer is 96. Remember, if it's a low number here, you might not even want to waste time using a formula. Let's find a sub n. So we want a sub 1 times r to the n minus 1. A1 is 3. The ratio is 2. Then n minus 1. And that's a good answer. Now, what some students will try to do is multiply the 3 times the 2. You cannot. Exponents come first. So you cannot multiply the 3 and the 2 together. Okay. Now, let's see if we can use this formula since we already know a sub n for this particular sequence. So this is going to be 3 times 2, and n is 20 minus 1. So that's 3 times 2 to the 19th power. When you punch that in the calculator, make sure you do 2 to the 19th first, then multiply it by 3. And if you do that, you get this very juicy number. I also want you to realize that you could have found a sub 20 by going right into that original formula, and it comes out just the same. A1 times the ratio to the n minus 1. And you see that's the same thing. 3 times 2 to the 19th. So either way, you get the same answer. For example 3, I've asked you to find the 21st term. Before we do that, I want you to see that it appears that we're dividing by 2. So 4 divided by 8 is a half. 2 divided by 4 is a half. So notice that the ratio is 1/2. Okay, we don't say dividing by 2. We just say multiplying by 1/2. Alrighty. So now a sub 21, we can use the formula. A sub 1. And let me write it out again for you. A sub n equals A1 times r to the n minus 1. This is our formula. So a sub 21 equals a sub 1 times the ratio times 21 minus 1, which is 8 times 1/2 to the 20th power. If you put that in the calculator, it's going to give you a decimal. So in order to avoid the decimal and to write this as a fraction, what you want to do is distribute the 20th power to the numerator and the denominator. So we end up with 8 times 1 to the 20th over 2 to the 20th. Well, anything to the 20th power is just 1. So in the numerator, we have 8 times 1. And in the denominator, we have 2 to the 20th power, which is over 1,000,000. And now we just need to reduce this fraction. I usually like to see what number goes into both. I'd probably just keep cutting them in half until I couldn't anymore. But we can reduce that. 8 goes into the top once, and 8 goes into the denominator 131,072 times. So just don't forget, you have to reduce. But that's how you avoid decimals. Let's look at example 4. The first thing I want to do is realize that the ratio is 2. And now we want to find the sum. So I want you to write down this formula. The sum, or S of n, for geometric, and see we have a different formula for arithmetic, is S of n equals a sub 1 times 1 minus r to the n over 1 minus r. Very important formula, and I want you to write this down. So now, if we're trying to do S of 16, then what we're going to do is start with a sub 1, 1 minus the ratio, which is 2, n is 16, over 1 minus the ratio. Okay, and your calculator should be able to handle that with no problem. And the answer is 196,605. Go ahead and pause and make sure that when you punch it in, you don't have a problem. Okay, make sure that you can punch that into your calculator. Example 5. Find a sub n if the first term is negative 2 and the fourth term is 54. Okay, I'm going to show you an easy way to do this. All you have to do is start with our formula. A sub n equals a1 times r to the n minus 1. And let's plug in what we know. Well, a sub 4 is where I want to start with the bigger term. A sub 1 I already know is 2. The ratio I don't know. N is 4. As a matter of fact, we know a sub 4 is 54. I'm going to substitute that in there. And now I can solve for r. So I'm going to divide by 2. I get 27. And I can take the cube root of both sides. Oh, I lost my negative sign. Oh, the 2 was negative. Yeah. So that should have been negative 27 right there. And now I'm going to take the cube root of both sides. And I get r equals negative 3. Now, in order to write a sub n, you only need to know a sub 1 and r. So now I'm going to go back, now that I know what r is, and a sub n equals a1 times r to the n minus 1. Okay, and that's a good formula right there. That's my a sub n. If you wanted to check it, you could say, well, this says a sub 4 is 54. So you could plug 4 in for the n and see if you actually get 54. So that's negative 2 times negative 3 to the third. Remember, exponents first, so that's negative 27 times negative 2 is positive 54. So we do see that a sub 4 equals 54.